This is a NASA work. Some of you may remember that I showed here similar work these guys have done with a mosaic with loads of galaxies. This is the last image from the deep sky from James Webb Space Telescope. So look at this beauty. This has more than 45,000 galaxies. 45,000 galaxies here. Every single dot that you see, almost every single dot that you see here, are galaxies. Guys, this is amazing. Can you imagine how many planet Earth like planets here can the universe have? Look at this. I will zoom it a bit. They have on that site, and you can download, if you like this kind of stuff, you can download the full resolution image. This is not the full resolution image, but it's, look at this, look at this. With gravitational lens here. This is James Webb again, evolving, improving, and providing us. Look at this, look at this beauty. This cluster of galaxies here. Incredible. This telescope will give us, this is a star, but the stars are rare. This is a star. Almost all the objects are galaxies, even the faint ones. Look at this, another cluster so far away. This is amazing. And it goes, it's super large, the image. Incredible, isn't it? James Webb. They are doing a very, very, very nice job with this tool that humans have. And I bet I'm anxious to see. Look at this, looks like a crown of galaxies here. I'm anxious to see if they can find even more amazing things that can reveal amazing things in the universe that we don't know yet. 45,000 galaxies in this image. More than, they said, NASA said, more than 45,000 galaxies here. But now let's understand what's behind that image, which is very important. As one important, very important object here that I didn't know. Let me go to the center of the image. It's right on the center of the image. You can see here, you see stars. Let me do like this. Here you see stars, you see with the spikes, they are kind of bluish. You see the stars. Here at the left also the stars. And look at this one. Right at the middle of this picture from James Webb Space Telescope, this pinkish object, it's not a star, it's a quasar. And this quasar is so important in this image that you will see now. That was the object that gave us all the knowledge that we didn't know, but now we know. Thanks to this image with this quasar here, the most powerful quasar known at this distance in time, because this was taken at the beginning after the Big Bang, just about 900 million years, so it was very close to the Big Bang. And this was the image that different institutions, not only NASA, but also cooperating with using not only the James Webb, this James Webb was essential, but also other telescopes in Chile, from ESA, from different institutions, together, working with other images, allow us to discover something. 1 billion years after the Big Bang, the gas between the stars and the galaxies was opaque, but then became completely transparent. And we didn't know why until now. This was stars forming and galaxies assemble. Look at these dots. Represent the stars formation and galaxies assemble. This was at the reionization phase of after the Big Bang. So the galaxies, what happened? Each little bubble here has a galaxy inside. So the galaxies began to change the gas around them. This is the gas, these bubbles are the gas around the galaxies at that time. Then they start to transform. You see at this picture here. The areas of transformed gas expand, they expanded, and then suddenly they clear, and the galaxies were separated. It's the end of the reionization. Reionization because they ionized and then they stopped and then they start again doing that process until they get cleared. It was the era of reionization. The universe was a very different place, and this phenomena happened. Now, they pointed to this quasar intentionally, because pointing to this quasar at the center, this one, this pink quasar, this is a quasar, it has a huge black hole, and it was intentional. And you ask me, why, Tiago? Because pointing to this bright, super bright quasar allowed these scientists with the James Webb and other telescopes on Earth to distinguish within the light of the quasar the gas which has popped because of the light. And watching that gas, they could analyze all of this and have evidence. This is a study that is not a proposition or an hypothesis or something or theory. They got evidence. And look at the galaxies they analyze. These are the second most important objects from this image. I don't know in this image, I don't know which are those galaxies, but they went deeper on these galaxies here, you see, to watch the transformation. This is very, very deep. This is in the early universe. All these galaxies that you are watching here were in the earlier universe. They are more chaotic, they say. They are more chaotic than those in the nearby universe. James Webb shows they were actively forming stars and must have been shooting off many supernovae. It was a young phase of those. It was only these galaxies that you are watching here, and this is amazing, was when the universe has only 900 million years old. Okay? They did this on purpose to point to the quasar, and they were intentional, pointing to the point of time which the universe was between the opaque time and the transparent time. They pointed to the middle, so they can figure out these kind of transformations. They said they will soon dive into research about galaxies in 5 additional fields. These results exceeded their expectations, so they will do now in 5 additional fields, anchored by a central quasar. the technique will be the same. The quasar, the light, to analyze the gas. It's one of the purposes of the James Webb. Until now, researchers didn't have this definitive evidence, this is important, of what caused the ionization. Before James Webb, they weren't certain precisely what was responsible. So this allowed us, this was 2 days ago, allowed us to start understanding much more of what happened in that beginning of the universe. The area that this bubble, the edge of the bubble, inside the bubble it's a galaxy, inside each bubble. This edge of each bubble has the distance to the core, to the galaxy, from the edge to the galaxy, is the same distance than the Andromeda galaxy to the Milky Way. This is a huge distance, but at the same time they look like subatomic particles. Quantum physics. This is amazing to watch the universe and think in the universe from these different scales, and you at the end you see the same stuff.